Okay, so this lesson is going to be on solving exponential equations. You've learned about solving equations a long time ago. We've been doing it forever. So you want to isolate the variable. You look at what's being done to it. You do the opposite. You do that on both sides. Times 2, divide by 2. Then you get your solution, of course. So solving equations is nothing new. Solving exponential equations is new. We're going to use something called the one-to-one property. I'll explain that as we go. But essentially, here's what it means. Like bases on both sides of an equal sign cancel out. If the bases are not like, then we can make them like. Okay, that's a weird looking H. Make them like. So that's our goal. The paper will be sort of in two sections. The first section will contain like bases, and you'll see how this one-to-one property works and how easy it is. The second section is going to be a little more of a challenge where we have to make bases like each other. Not make them friends like, I like you, but make them alike. So here is the paper for today. And I realized yesterday I did something foolish and I only posted notes and I didn't post an assignment. But today it'll work out the way it's supposed to. I'm going to do the evens. You are going to do the odds, just like a normal school day. So, number 2. This is an exponential equation because the variable is in the exponent. And we want to isolate that variable. And that seems kind of challenging. But the base on this side is a 2, the base on that side is a 2. Because they are like bases, they both are 2's, you're allowed to just cancel them out with each other. And then you're left with a plus 2 equals negative 3a. From there, you're just going to use basic algebra skills that you've been using for years. So we'll do this, get negative 4a, divide both sides by negative 4. A is isolated. You can't divide 4 into 2, but you can reduce that to negative 1/2. And there's the solution. I'll scroll down to check that, which was at number 2, and there we see negative 1/2. So that's the one-to-one property. We've got one base here to one base there. They're equal, so they just cancel each other out. Negative 2b equals 1 minus b. Then we can maybe add b to both sides. Negative 2b plus 1b is negative b equals 1. Divide by negative 1, and we get b equals 1. So that is solving exponential equations in the most simple form. I'm going to scroll down real quick to look at number 4 just to make sure I have it right. Of course, it's right, negative 1. Now, number 6, the bases on both sides are not the same. We have a 4 here, we have a 16 there. So as I said a few minutes ago, if they're not the same, you make them the same. And here's what I mean. 16 can be thought of as 4 to the second power. 4 times 4 is 16. I mean, you can think of 16 a lot of different ways. It's also 15 plus 1, but that doesn't really help us. If we turn it into 4 squared, now we have a matching base with this side, which we can just cross out. Negative 3n minus 1 equals 2. Add 1 to both sides. Negative 3n equals 3. Divide by negative 3. N equals negative 1. So the bases did not match. We made them match. We turned this one into a 4, and then we can solve that equation. And let me see. Number 6, yes. Number 6 is also negative 1. Let's look at number 8. So the challenge now is, can I take 81 and change it into a 3? Now I know I can because I do math a lot, but you might scratch your head a little bit and say, you know, what's the deal with that? How do you turn a 3 into an 81 or an 81 into a 3? So one tip is to grab a calculator and start multiplying 3's together. 3 times 3, and there you see is 9, times 3, times 3, and now it says 81. So it took 4 3's to do that. That means this is 3 to the 4th power. Now these cancel out. Negative 2x equals 4. Divide by negative 2. X equals negative 2. So you can use the calculator to sort of help you out a little bit. Let me check number 8, and there it is, -2. Number 10. So this one's going to be a little bit of a challenge. Can I make these bases match? Well, I'm going to do that same trick. I'm going to go 25 times 25. And there you see it, 625. So I can turn this 625 into a 25 squared. But what about the power that's already there? Well, it's still there. Let me bring this down. So this is what we're looking at here. Oops, there's an R there. So we got the bases to match. I turned 625 into 25 squared. I use the calculator over there to the right to do it. So, okay, I cross these out. I get 2r here. But what do I have on the other side? Well, on the other side, I just multiply this and get -6r minus 2. Remember, when you have a power to a power, they multiply. Now I can add 6r to get my like terms together. That cancels out. -2 plus 6 is 4r. Bring down the -2, divide by 4, and then -2/4 reduces to -1/2. And let me check number 10. And there it is, -1/2. Okay, so that was a little tricky. We were able to change 625 into 25 by messing around with the calculator. It's 25 squared. Then we have a power to a power that has to multiply. Now, number 12 is going to be a little special, kind of tricky. Am I going to change this 32 into a 4? Well, let me do the same trick on the calculator. 4 times 4 is 16. Times 4 again is 64. We've shot past, excuse me, we shot past 32. So it doesn't look like that's going to work. So here's the trick. I cannot turn a 32 into a 4, but I can still make the bases match. What I'm going to do is I'm going to turn both bases into a 2. 4 is 2 squared to the -3k. And then 32, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. That took 1, 2, 3, 4, 5 2's, 2 to the 5th power. So I couldn't make the bases match directly. I kind of had to go a little indirectly. I turned them both into a 2. Now those bases cancel out. Again, that's the 1-to-1 property. On the left, I have 2 times -3k. That's -6k. On the right, I have 5. If I want to isolate k, I'm going to divide by -6 because they're multiplied. And you get a fraction that does not simplify. You can bring the negative out front of that fraction bar, but other than that, they don't really divide out. We're not really looking for decimal answers, I don't think. Yeah, no decimal answer, just -5/6. Number 14, well, having done number 10, I already know the trick for number 14. 625 is 25 squared. And then I bring down the v plus 1 power. Over here I have 25, 2v plus 2. The 25's cancel out. I multiply this and get 2v plus 2 equals 2v plus 2. We've got variables, like terms, we need to get together, so I'm going to subtract 2v on both sides. This cancels out, and we get 2 equals 2. Now this is kind of special. Remember, the whole goal of solving an equation is to isolate the variable. We want to know, what does v equal? Isolate the v. But the v's are gone. You can't isolate it if it's gone. And what we're left with, 2 equals 2, is a true statement. So if you recall, this has happened before in class. If the variable completely disappears and you're left with a true statement, that means all real numbers are the solutions, or the symbol for that is that funny capital R with 2 sticks on it. So let's look at number 14, and you see right there, all real numbers. Okay, number 16 is left, and this is kind of tricky. What can you do? How can you make these bases match? I mean, can I turn a 1 into a 4 by multiplying it by itself over and over? No, you multiply 1 by itself over and over, you still just get 1 for an answer. So then you're thinking, okay, how am I going to multiply 4 by itself over and over and over to make it equal a 1? And you can't do that. That doesn't make any sense. Look, 1024. Well, let me remind you of a very special rule in exponents. There's a rule of exponents. If you take any base, I'll use a for any number, any base raised to the 0 power, it always equals 1. Let me take the calculator. So 5 to the 0 power, see right there is 1. 22 to the 0 power equals 1. Even 4 to the 0 power equals 1. So I can turn this 4, I'm going to leave this a 4. I'm going to change this 1 into 4 to the 0 power. So anything to a 0 power equals 1. That means I can make this 1 into any base I want. Just stick a 0 power on it. Now the 4's cross out. Negative 3x equals 0. Divide by negative 3. And x equals 0 is the answer. And where's the answer, number 16? There it is. X equals 0. So try the odds, use these evens as examples, and watch the video again if you need to. Pause it, rewind it, whatever you need to do. Work hard on your assignment, and then have a great spring break. Talk to you later.